I was originally going to leave at 3:30, so I'm sticking around a little longer. But there's a bus at 5:30. There's still a ticket.
Okay, no more until like.
I don't even remember. You
Nejaká
sleep
voda?
on the floor.
Oh, yeah, I can sleep on the floor today. In the rooms yeah, we just search for a hotel.
Ideme to akože na mute, hore.
I had no trouble finding
Jo.
it. So,
Stay in a hotel.
Keby niečo, tak ja budem ukazovať čas. Jo?
I can get you the possibly,
You were going to leave at 3:30, you said?
but now I'm going to stay at 7:30. Unless you can have my ticket, because I
Okay.
have to buy a new
1, 2, 1, 2.
So if you want a 3:50,
So you had to buy a whole new ticket.
yeah, for €10. I mean, it's not.
Yeah.
So it's not going to break the thing. But yeah, they won't let you change less than 5 hours.
We should add an extra ticket for the
You might get
5:30.
for the 3:30.
For the 3:30.
Yeah. You can try and use that.
Yeah, I will check out the hotel.
OK, tak já jsem to tady. Zkuste tady, co to přepne. 1, 2. A. Teď to.
Teď to zase.
Nevím. Tak já jsem mu tady ruční. Tak já jsem mu tady ruční.
Jo? Alright, so we can continue after the break with next talk by Michal Hrušecký about openSUSE service.
Hi everybody, thank you for showing up. And let's start with a little bit more introduction about myself actually. I want to tell you about my previous experience, so you would know, because mainly I'm not that much part of Fedora and CentOS community, so most of you don't know me yet. So I want to show you a little bit about my background, so you would know why you should actually pay any attention to what I'm saying here right now, and to show you that I actually know a thing or two about what I'm going to talk about. So, who am I? I used to be openSUSE packager for several years. I was part of openSUSE boosters team, and openSUSE boosters actually in past few years helped heavily with managing openSUSE releases. So we were at the center of things where releases happened. And currently I work as open source software engineer at a company called Eaton, which is not that important for you, but in general it's really nice example. Eaton is actually a hardware company. They do UPSs, circuit breakers, engine parts, and stuff like that. And then they realized that they cannot continue into the future without investing into open source. So they are starting to embrace open source nowadays. So that's cool. A few years ago, we were the weird guys, and now even companies that don't do software, they are really interested in open source. And when I joined Eaton, we were starting a new project, and it was already decided that it will be on Linux. And unfortunately, it was already decided that it will be on top of Debian. I have a question. Did any one of you try creating packages for Debian? Okay, quite a lot. And who of you liked it? Okay, 2 guys. So yeah, we had a similar experience. So we tried to push for at least a little bit better build system that what Debian guys have on their tutorials. So we pushed for openSUSE service. We got it, and because I was part of the pushing team, I'm now maintaining it. That's how it works. So, how do you make a distribution? Basically, you've got this continuous stream of packages coming from developers. They want to have them in. They want to have them in fast. And if you don't have any update yesterday, then everybody is disappointed because it's going too slow. And yeah, it's old news and it's boring. Then you need to get some binary packages out, and you need to create some ISOs so people can actually install it. And when you actually release the distribution, then you have some QA guys that needs to check it. They work against these developers guys, because these QA guys, they want to show the developers that they are good for nothing and they make only errors and they never did anything right. That's their job. And they are trying to work against them to push their updates. And then you have security guys that are a little bit different as well. They don't want to update anything unless there is a security issue, and then it has to be fixed yesterday. So you have these multiple guys, and every one of them wants something completely different, and they work against each other. And then you have a release manager, and he has to talk to all of them and make all of them happy and make it somehow work in the end. So that's a really hard job, and it's even harder if you don't have any tools to help you with that. And also, yeah, if you are making a distribution, you probably want to sign it somewhere so people actually can trust your packages. And it has to happen somewhere in the middle. So what is OBS and how it can help? It's an open build service. So it's open source software, first of all. So you can use it. Even inside your own company, behind firewalls, don't let any contributors from outside help you. That's possible. It can build stuff. That's what we basically want if we are doing distribution. And by stuff, I mean mainly packages and also images, if you want to have these ISOs so people can install it, or some images that you can deploy in cloud or wherever. And the last part is the service. It's running on the server. You can have multiple users accessing it, cooperating, working together, and it actually manages some queue of the building packages. It can use other hosts to build packages. And it has some cool features. That's the good part. It builds stuff. Actually, it builds stuff on top of other stuff. You can actually have some project with some distribution, then you can create another project based on this one and just switch one package and try how it works out. It also manages some requests. Do you use GitHub? Yeah? So you know these nice pull requests that everybody is happy about? So it has something similar. You create you go to the build service, there is a package that you don't like how it's made. You create your own fork, you create a request, and then the developer of this package will get the request, he can take a look at it, he will see the diff, he will see whether it built, and he can discuss with you about the stuff, and at the end he will either accept it or decline it. And yeah, it helps with cooperation and working together. As I said, as you can create forks, and as I said that it builds stuff on top of stuff, it's really easy to create your own repositories that can be added to your distribution. So whenever you feel like it, you create a new repository with a bunch of packages that you would like to have in one repo, and it's there. And to help you start it, you can actually take binary packages and import them, or you can import source RPMs, and this way you can bootstrap the build service if you don't have anything inside. And Other interesting feature that I would like to mention is out of the box, it supports QEMU user mode. I don't know whether you heard about it. It's a way how you can run just single binary using QEMU for different architecture. And this way you can create a change root. And then in the change root you can run, for example, ARM binaries on x86 without actually booting the kernel and simulating the whole machine, just emulating on per process basis. So, how all these features can help us with creating the distribution. So, we have these impatient guys that would like to push their updates as soon as possible and get it to the users, and we have some users that would like to get updates even sooner. So for these guys, we have these repositories that they can create and they can manage it on their own. So if you are a release manager, you don't have to always accept the request. You can point people, if you are impatient, try this guy's repo, and if it breaks, it's not my fault, it's his. And it also helps actually those developers because they can create a repository with some changes to test, and they can test them easily. They can see when something breaks, and they can fix it before actually pushing it to the distribution. So this way we can actually calm these impatient guys. Then there is still plenty of packages that are coming in. So what you can do is actually assign multiple roles to various people and let them do the reviews. So you can take few QA guys and tell them to look at the queue, and when developers come and they start asking why is not my package in, this QA guy will tell them that they did it all wrong and they should redo it, and you have few days free from them. There's also something that we use at openSUSE, and that's called staging project. It's basically the building stuff on top of stuff. We create a separate project for some requests, and then we try to rebuild part of the distribution to see what broke. And there can be multiple reviews. Some of them can be automatic, some of them can be manual. And the important part is that all these reviews are visible in Web UI. So people that actually created these requests see what is the current state. So even if there is, if it takes a few days for a package to get in, they get a notification, now you passed this review, now you passed this test, now you pass this. So they know that somebody is taking care of it and it's not stuck somewhere. So let me show you a few pictures. This is actually a queue of requests going to openSUSE factory. I took a screenshot, I think, yesterday. And you see who submitted what. And you see that most of these are in review state. So somebody is looking at them. You can see when they were submitted. And as a developer, you see basically how many people were in the queue before you and after you. So you can check people before you getting out of the queue, and you are getting closer to your turn. And for every request in openSUSE, we have plenty of reviews. Some of them are automatic, some of them are manual. So as you can see, this is one of the requests going to factory. There are some requests for reviews. Then some reviews got accepted. And when everything got accepted, whole request got accepted and package ended up in our development distribution. So I made a graph with a lot of arrows, and it looks really complicated, but it's not that much complicated. It's actually, we created openSUSE. We have openSUSE Tumbleweed, which is stable rolling distro. And I would like to show you how we did it using OBS. So let's start from the beginning. We have some develop project where developers created new packages, for example, new KDE, and they send it to develop distribution or to the rolling distribution called Tumbleweed. But before these requests get accepted, there has to be some review going on by some people, and some are automatic. And we also, if it's core enough package, then we create a staging project, which will basically take what is already in Tumbleweed, add a few packages to it from few requests, and tries what is going to break if we mix it together. Before we actually merge it in, we try it out first. And out of this staging project, we get not only the build results, but we also get some basic image, which we then push to OpenQA. I had a talk last year here about OpenQA. It's our testing tool. It basically tries to boot things up. It tries to install the distribution, and then it tries few basic applications, whether they work. Like you can start X, you can open Firefox, so you can connect to the network. So basic operations should work. And when this passes, then staging project gets accepted. And if reviews get accepted as well, it ends up in Tumbleweed. After rebuild of Tumbleweed, we run OpenQA again, just to make sure. And if it succeeded, we publish it. So if there is any breakage on the way in any of these points, then request gets declined and people have to fix it. And because staging projects are much smaller, there's much smaller amount of changes than in actual distribution. It's much easier to point fingers and tell who actually break it. We still have plenty of packages in distribution. We don't have only systemd and GNOME. We have other guys as well, at least for now. So we need to be able to tell who broke the stuff and who is supposed to fix it. Yeah?
So is a staging project something that is outside of Tumbleweed, are you saying?
Yeah. Question was staging project, whether it is something outside of Tumbleweed. Yeah, it's basically repository on top of Tumbleweed. And as the build service is taking care of tracking dependencies, when you inject their package, it will rebuild itself, and it will also rebuild all the packages from Tumbleweed that are depending on it. It's not actually a whole Tumbleweed. We have Tumbleweed divided into several cores or several groups of packages, and we don't do the leaf packages. We do just the internal ones, the more important ones. But yeah, basically it's one place where it cannot break anything else, and when it gets either accepted or declined, we can stage whole staging project and create a new one. So nobody can break anything, and we can safely test whether the update is easy, and not easy, but if it is safe. So then there is this stream of packages going out. If you are making distribution, that's basically automatic. There's nothing much to do about that. Build service, when you change something in the project, it will try to build everything, and once everything is built, it will publish it. It wouldn't publish stuff when there's still something building, because that way you can get into troubles, because, well, you can have a newer version of library and package built against the older version that is no longer there. So as long as something is building still, it wouldn't publish it. It signs all packages, and we have a nice web UI that you can check and see the progress and how stuff is going. And as I said, when there is a change to some package, it will also trigger all the dependencies. And therefore, if you are managing the distribution, you just take a look at the queue of the requests that you have and accept some of them, and OBS will do the rest. You don't have to care manually about the dependencies. It will track it for yourself. Now, let's get to some bad parts about OBS. It has its own version control system, no Git, and it uses some suse-build script, so no mock, and it's actually written in multiple languages. We have a backend, which is written in Perl. We have frontend, which is written in Ruby on Rails. We have CLI, which is written in Python. And the build script that actually runs everything, that actually builds your packages, is written in Bash. Yeah?
OBS and Tumbleweed? Is the software for the OBS itself in the OpenQA testing system?
Whether it's OBS software tested by OpenQA, I believe, I'm not sure whether by OpenQA, but we have unit tests, and it's actually tested, even though it's a mixture of such languages. Now, it sounds scary, so let's take a closer look. About the own version control system, you actually don't have to use it if you don't want to. There is something called services inside OBS that allows you to do plenty of stuff without actually using the version control system. You just trigger it and it will do some magic, and you will end up with sources for the build. It can fetch sources from version control system, so for example from that Git. It can fetch tarballs from websites. It can do some simple modifications, and you can extend OBS by writing your own services. I tried to put one of the recipes on one slide, so it's a little bit hard to read. But basically, what we have here is that it uses Git. It will download some repository from GitHub. It will create a tarball, and there will be some version prefix. So it will be tarball named my project -04.git, and there will be some hash that identifies the checkout. You can also specify which branch or tag you want to check out. Then it can extract some file from that archive that it created. For example, the spec file, if you have it in Git, then it can extract it and compress the tarball, and set version is a simple service that will modify your spec file to have a newer version from the Git tarball you just created. So this complicated thing basically can be used, for example, if you are going to package your own upstream software. So you put just this one file in OBS, and then you just poke it, and it will do everything and rebuild the packages, and you don't have to touch the version control system that is there. And as I said, you can do your own services. So we did so at Eaton. We created a simple service because we have everything in one Git repository. We have some procedures where to put tarballs, and it's really predictable. We basically copied what you guys do at Fedora, almost. We just have one Git repository because we have something like 5 packages, so we didn't want it to split it per package. But we made it easier than the previous service. We wrote our own, and because if you are writing the service, you know the name of the package, you know the name of the project you are in. So basically, we just hard-coded our paths to our internal Git server, to our NAS server, and this is all you have to put in. And then outside of the package name and outside of the project, it will construct which directory inside the Git it should check out. And from project name, it will figure out what branch we want to build. And we also have the sources file, as you have in Fedora, and it will go to our NAS server and download the correct tarball. So if you want to customize it to serve just your needs, you don't have to go with the complicated generic part, but you can write your own service that wouldn't do everything, but it will do just the thing that you need, and it will be much simpler. Now let's talk about multiple languages. It has some advantages because no matter who you are as a programmer, you can contribute. You just need to select the correct part of the build service. I know last year when I was talking here about OpenQA, some guys complained that, yeah, we don't do Perl, we do Python. We would prefer something in Python. So OBS has Perl, Python, Bash, Ruby, whatever you like. And actually, it's consistent per part of the build service. So if you are dealing with backend, it's only Perl, nothing else. If you are dealing with web UI, it's only Ruby on Rails, nothing else. So there is a clean distinction per parts of the build service. And inside the part, it's only one language, apart from the services. Services are a way to extend OBS, and you can write them in any language you want. So if you are missing Go, you can write your own service using Go or whatever. And the last part that I had on the bad parts of the OBS, this suse-build script. It doesn't use mock, but it has pretty similar functionality, at least from what I understood that mock is. It can create change root, it will install packages inside, it will build your package. Okay, it's completely different?
A spec is not interpreted inside a clean build root with some base packages. A spec is interpreted outside of the build root.
So in mock, you are interpreting spec before entering the change root?
No. In mock, we built a build root with a minimal RPM config type of stuff, with your minimal GCC, if you will. Then you interpret the spec, and therefore your build dependency chain is exactly the target platform's resulting of such a build dependency chain. And everything else in the spec is exactly the target platform.
Yeah, I still don't see much of the difference.
I don't think that
But
makes it completely different, but there are some differences.
yeah, so there are some differences.
It behaves differently if the host system has a very different RPM or a very different dependencies
Okay.
from the system inside the change root.
Okay, yeah.
That's another topic.
So yeah, there is a So the outcome of the discussion that we had here, just for the record, is that there could be difference if your built environment is has completely different resolution of dependencies than your built environment, because because dependencies are evaluated before and change root is created before actually entering it. Okay.
Also, mock can't build devs, so it's different that way too.
Yeah, I didn't get to that part yet. So yeah, the other difference is that suse-build can build not only RPMs but also deps, and it can also build Arch Linux packages, and it can also build images, so ISOs and other images. Okay. But it can be extended to do some more. If you want to build some other crazy packages, then you can extend it, but in that case you would have to dig to OBS as well, and there's this change in the languages from Bash to Perl. And but if you want to just bend it to your needs, and you need just RPMs or deps, then it's quite easy, and you can just modify it somewhere and get into the change root and change something there before actually creating the package. So now to the interesting part. When I was playing with OBS, I decided before I go here to try to build CentOS, just for the fun of it. So I just took, yeah, question?
CentOS 6 or CentOS 7?
CentOS 7. I just took binary RPMs, imported them into build service. I took source RPMs from CentOS, imported them as well, and let it run. It ran for a day, and then I got this. So I got something almost 300 packages failing. The rest of the, almost 400 packages not building. The rest of the CentOS was built out of the box without me actually touching anything. The point of this experiment was that I'm not going to work on it, and I want to do as minimal work as I have to actually go anywhere. And yeah, I was being lazy, and I was trying to go as far as I can without actually breaking the rule of being lazy. So what failed? I found out that there is probably something that we handle differently, and that's debug files list. I failed to, quite some packages that failed were not able to find this debug files list file for some reason. When we are building packages, we are using already the RPM from CentOS and other stuff, but from outside we are maybe not doing all the magic that you do. I know that debug packages are different and sometimes quite magic. So what I did was, I was lazy, so I just created the file, empty even if it wasn't there, and tried how it helps. And it got me some pretty interesting results. So now I'm at about 150 packages that are left. And what else failed? I found out that there's also something about handling man pages. Usually man pages are quite tricky because every distribution has some tricks to it. Sometimes you don't touch them, sometimes you recompress them no matter what using zip2 or LZMA or something else. I also found that quite some packages has bogus dates. If you take a look, then it's not quite probable that there will be Tuesday on 9th of February and 4th of February at the same time. And it actually turns out that neither of these days is Tuesday. Yeah, well, we treat them like errors.
Yeah, I think in Fedora and Raw, for example, it was also an error, but then it got downgraded to a warning because it failed too many builds.
Yeah, so you know about that.
Someone was up very late.
Yeah, we actually have a nice command in OBS when you do OSC VC. It will actually prefill the date, including the day in the week.
That exists in RPM. Just
Yeah.
RPM tools. You can extend the spec and tell it to uninstall RPM lib, and then it goes through.
Okay, so you can disable the check. Yeah, I just ran a different script on it, so I just got rid of changelog completely. And I also fixed few dependencies that build service wasn't able to somehow resolve by itself. I don't know why, but it might be due to user merge that you have. Yeah?
No, the OBS resolver does not do file dependencies.
Doesn't do what?
File dependencies. So we might have a build requires /bin/set, but it isn't resolved by the OBS resolver. So set is not being pulled in.
Well, I think it is because it works for some of our packages. So I haven't looked into.
So you can have a project config that then says /bin/set is actually the package set.
Yeah, so I don't know why it failed, but I did few of these simple changes by hand, and as I said, I was trying to keep my work at the minimum. So in the end, I haven't spent more than 1 hour on whole this project.
Fair enough, but I'm just explaining you how that.
Okay, and let's take a look at the final result. That's where I ended up. The rest looked like too much work, too much digging around and finding out what went wrong. But I got most of the CentOS built, just under the less than 100 packages failing. And the general overview of what I want to convey by this talk: OBS is out there. It can be bent to do whatever you want. It can build almost the whole CentOS and does plenty of stuff automatically. And it's quite easy to use, and it provides nice UI, and it shows what's going on at all the time. So it might be interesting to check out. I know that some of guys from your community were looking into it. So thanks for the attention. There is some feedback link on DEF CON website, so you can provide me with some feedback. And now, if you have some more questions or comments. Yeah, question?
Can I build several package formats from one source repo, like pull in from Git, for example, like build RPM, deb, or arc package?
So yes, you can. Unfortunately, because there are different recipes, if you want to do packages for multiple distributions, then you have to have recipes for all the distributions. If you want to do RPM-based one and Debian-based one, you have to have spec file and then a whole bunch of Debian files. But if you want to do Fedora 21, CentOS 7, CentOS 6, openSUSE, and SLE 12, then you can do everything from just spec file and from one spec file. Yeah, some more questions? Okay.
Do you know if there are any plans to support Docker, OS3, or any of the cool stuff that's happening?
Whether it is possible,
Containers and stuff.
whether it is possible to, whether there are some plans to support Docker, containers, and other cool stuff. Well, for building, OBS actually can use some of the machines in virtualized. The build nodes can be virtualized. I know that it can use pretty easily QEMU, I think I saw somewhere some support for Amazon Cloud. And Docker is basically just a Linux container, so...
Right, but I mean producing, not using.
Oh, producing. Well, as I said, it can build images, so you can create images. I'm not sure about how much you have to modify them to be Docker ready, but for ordinary purposes, images are out there. And there is a nice tool called Kiwi that can create images with plenty of options from RPM distribution. For Debian distribution, it's a little bit harder.
I was just going to say, you don't have to do barely anything to an image to make it into an image can easily be turned into a Docker base image. So it should be able.
That in your sexy voice.
That's just my voice. Sorry.
Okay, so thank you.
Great. So
Thank you, and see you around. If you have any questions, catch me out.
Jo, díky.
yeah, well, no, I was just going to introduce myself. So I've worked a little bit on coding, some parts of that integration. I'm going to give a talk at Scale conference in California about a week and a half. And I want to talk. This is a portion of what I want to talk about. It's supposed to be a distribution of this record. It's going to focus mainly on Fedora. This already teaches me a lot that I didn't know about OVS.
Yeah, there will be some of the guys from us at Scale. I'm not sure. Yeah.
Can I? Here, I'll take a picture of you. I'll follow you on Twitter or something. Or do you have a card?
Base images are
Yeah. Oh, yeah.
layer and tracking.
Let's go with this one.
Okay.
Something
I don't have any. So, are you on
Yeah.
Okay.
Yeah, if you have any questions, I think my email should be on as well.
It's sacred to us. The release tag is sacred to us. So even though you say it's absolute shit, you actually need to use it. So, but you know, the thing is, everyone who uses code ends up saying similar things. It's a difficult problem to solve. Yeah.
Môžem ťa poprosiť potom skopírovať prezentáciu na USB? Jo?
No to potom.
To je tam, jo?
She'll also find people like Colin Keith.
Or they didn't provide any, so if it's not here, no. That is point half
One. One.